Hi everybody, and welcome to this video on building web applications with bfabric WebApps Python library. I'm Griffin White with GWC. First I'm going to be going through a little background of this library, how it's working, and then we're going to be developing a Hello World NF Core application together. So invoking NF Core's Hello World pipeline via a bfabric web app template. Okay, so a little bit of background. Why we chose dash in Python is because we wanted a stateless single element stack paradigm that we could build in a really straightforward and simple way. Dash offers us this, so we didn't want to add any databases. So in general, the complexity of a system scales quadratically with the number of data stores to synchronize. So we wanted a totally stateless application paradigm that we could kind of mount on top of bfabric using the bfabric API to communicate all of the different data integration steps. Okay, so speaking of those data integration steps, the relevant entities for the bfabric web applications are the application itself, the app's parent. So apps can now be mounted to a variety of different entity classes. That includes plates, runs, samples, containers, work units, resources, data sets. The job object, which is where all of the various activities of the application are logged, and then the work units and resources, which is essentially the data which is created by this. I left a couple off here. One is the data set, which is connected to the work unit by default via the run main job function, which we'll cover in a second, and the charges, which are created every time you run an application if you choose to charge for the application invocation. Okay, now the three-step dev process. I've tried to break this down into three pretty easily understandable components. So the first is just to collect user data. So the first task we have as developers building this application is to collect the user data. So that means building a sidebar where the user can select different options from the drop downs or type in some input, validating this input, and building the sidebars and callbacks for doing that. Then the second step, which is usually already done for you, is collect bfabric data. So there's a lot of bfabric data which is already loaded into the application templates whenever it's invoked. So usually step 2, you don't have to do anything. If you have a highly customized app with special use case, then you might have to collect additional bfabric data, but the information about the user, the app, the entity, the job, all of that is already stored in the user's browser natively in the template whenever they click to invoke an application. And the third step is to invoke the underlying application. So the source code, let's say, in this case, we're going to be running the nextflow Hello World app. And so the third step is just to invoke this application in a way that integrates tightly with bfabric. So we do that using the run main job function, which we'll see live in a little bit. But the run main job function is essentially a wrapper for any arbitrary bash commands, which integrates your invocations tightly with bfabric. So it allows for easy resource creation parameterization, easy work unit creation parameterization. So it automatically creates and links the resources to the work units. It automatically logs everything to the job object. It attaches the work unit to the job object. So this data is integrated. It copies input files to a working directory. So if there are sample sheets or config files that you need in order to invoke the underlying app, then this is copied over. You just pass it as an argument to the function. It invokes an arbitrary number of bash commands, which are passed as strings to a list arguments to this run main job function. So it can run runs arbitrary bash commands. Indeed, this is the central point of this function, is to run these bash commands. In our case, nextflow run hello world, which you'll see. Then it creates charges for this invocation. It creates a data set. It links the data set to the work unit. And then again, it logs everything to this job object. So without further ado, let's get started. So the first thing we're going to do is fork the template repo. So a lot of generalized stuff has been built into these templates. We're going to go into the bfabric web app template repository, and we are going to create a new repository using this template. Okay, we can say NFC hello world. NFC hello world. Description, an NFC hello world application. Okay, we can make this public. So another note, this paradigm was kind of inspired by the complexity of existing systems. So we wanted to make a system which is a little bit more simple for debugging. So rather than programming everything in bfabric and modeling everything in bfabric, you can program and model some things directly in your own code and then manage directly where you choose to invoke the actual underlying applications. So all of the infrastructure is under your control. So this is a little bit more hackable, let's say, observable, and potentially transparent depending on the use case. So that's kind of the reason why some design choices have been made while developing this paradigm. So cool, we built our NFC hello world. We have a bunch of stuff out of the box, the README for the template. So there's all kinds of functionality we get just for free by using this. Now I'm going to switch over to my VS Code, and I'm just going to clone this repo right here. Repository is cloned. We're going to cd into NFC Python 3 minus m venv to create our virtual environment. We're going to source venv bin activate to activate our virtual environment, and then we're going to pip install -r requirements.txt, and this is going to install all of the project dependencies. Okay, the next thing we're going to do is copy the .env.example file to .env. So we can cat our .env file, and we are going to need to update some of this stuff. Nano.env. So I am actually running Redis on a different server this time. So I'm going to point it to my server where I'm running Redis. This is just going to be the IP address of whichever server you are running Redis on. 179, 128, 251, 128, 179. Okay, Redis port is still the default port. My bfabric config. This you can find instructions for setting up in the repository. I'm going to run on localhost port 8050 for now. Let's set debug to true since we're developing. I have my developer email address, my bug report email, these are both fine. And then I'm gonna parameterize my GStore remote path, so where are the files gonna end up. And for testing, I always use this server, GStore projects P2220 GWC. You can set up a folder in there if you wanna test stuff out. And then a Scratch folder. Please make sure that you have already created this Scratch folder on your execution environment. TRX login. We're going to log into FGCZ -c -043.uzh.ch. I'm going to point it to my Griffin.ssh TRX copy. And we're going to provide the URL. This is the URL where reports are going to be pointed to. So fgcz -gstore.uzh.ch/project/p2220/GWC. So all of my reports that I'm going to create and link are going to go in this directory, and they're going to be served via this URL. So then we're going to write the service ID. A little note on this. This is going to be just the ID of a service which you want to charge. Here we can take a look. at which actual service I'm talking about here. So if we go to charges, yeah, it's this consulting and data analysis. Normally you would create a specific charge for your application. This one I've even disabled just so that nothing can actually get charged, but you would just pick an ID of a service which you want to charge for when the user invokes this application. That's my service ID 143. And then my dataset template ID, I'm gonna pick 14. I just created, you're gonna also wanna make sure that you create a dataset template ID if your application is indeed creating datasets. So we can take a look at these dataset template, which I've created, ID 14. This is just NFC Hello World. It's just a small dataset with a resources and attachments column, and it's just used as a kind of placeholder for this application. Yes. Okay, back to our .env file. Now that we have completed this file, we can save it, exit Nano, and now we're going to actually register the application in bfabric. So we're going to do that by running Python 3 scripts bfabric apps auto registration. We're going to register it in the test system under bioinformatics. This is going to be NFC Hello World, and the URL is going to be http localhost 8050. Okay, and then the description is a Hello World app from NFC. Okay, and then this application has been created. The last thing I'm going to do before we get started developing is go over to this application in bfabric and bind it to an entity. So we have this NFC Hello World app. I'm going to just quickly edit it, and I want to actually bind it to datasets. So this application should run on a dataset and produce another dataset. So I've saved it, and now it's bound to datasets. And if I go to any kind of dummy test dataset from demo test app, for instance, we can see NFC Hello World shows up here. Right now the app is not running, so this will spin its wheel for quite a while. But you can see it can already be invoked via the bfabric interface. Okay, so the last thing I'm going to do before we start developing, I want to use the Redis template for developing this app. So I'm just going to run Python 3 index Redis to run the Redis template. We can see it's running on localhost 8050, and then I just want to test that this is indeed running from bfabric. Actually, first I need to go to VS Code and forward the port. So you can do that in VS Code. In PyCharm it's similar by just control click. It opens a browser session, and this app is running. We're not yet logged into bfabric. So we're going to close this, go over to bfabric and invoke NFC Hello World because our port is forwarded now. Okay, now this app is running. Great. So now I'm just going to give you a little bit of overview about what is actually in this template before we start developing. So we're going to open this folder into our environment. NFC Hello World. Okay. Yes, I trust the authors. So you can see our index Redis is here. So let's just go through this quickly. So what's going on here? This sidebar, this is the sidebar that you see in the browser. This charge switch is the component which is imported directly from the bfabric WebApps library, which allows the user to switch on or off whether they want to charge the underlying container for this run. The rest of these are ultimately HTML components written in Dash's convenient Python syntax. So this is just the sidebar. We also have a modal, which is another component attached to our application. This is the confirmation box which shows up when you click submit that asks, really, are you sure you want to run this application? And this is just nice, gives the users another confirmation before they trigger an app. There are a couple alerts which come up. So there's an error alert which comes up if there's any issues. We handle some errors inside this app. There's a success work unit created message which comes up. And then there's the app specific layout. So this is the actual dash layout that is the body of the application. You see we have our alerts, we have a modal that we parameterized earlier. We have one column which is containing the sidebar, and we have another column which is containing the page content. Dash is really straightforward, especially if you've written in Python or HTML before. If it looks a bit weird at first, it takes a little bit of getting used to, but then it's really easy. You'll be spinning up these dashboards in no time. It takes very little time. So the documentation content, this is the content which we find in the docs tab of our application. This is, again, just strings wrapped in dash components, dash HTML components. We have the app title here. We have the app layout, which is specified via this get static layout function. This is imported from the bfabric WebApps library. So we have our app title, which we wrote, our main content, and our documentation content. We also have a layout config which specifies which tabs should show up in the app. The work units tab, true, queue, yes, and bug, yes. We want people to be able to submit bug reports in this app. So this first callback is just toggling the modal. So it closes the modal when you click accept. I'll show you that in a little bit. This is the callback which is preventing users from clicking anything when they're not authenticated. So this just disables everything. You can see our output targets here are the disabled parameter of all of our UI components. So this is the callback which is disabling the user from clicking things when they're not authenticated. And then this last callback here, this is the submission callback. The most important, indeed, the whole point of this application is to gather all of the information from the UI components, organize it here, and then create our dictionary of arguments, and then ultimately submit this job to the queue for invocation. Okay, so before we get started using this template, I'm just going to delete some functionality from here that I know that we're not going to need. So this submission callback, which is highly customized for the individual application use case, you can just delete this straight off the bat. We're going to write our own. This UI interaction callback, we can as well delete this. We're going to write our own version of this. So we're going to have our own UI components. We're going to remove this one here. The other thing we are going to do is just remove all this documentation. We can leave one of these and say welcome to the NFC Hello World application, and we'll just say this app is an example of how to invoke NFC pipelines from bfabric web apps. Great. And if we open our terminal and run this, of course, all the changes are immediately reflected. Python 3 index. Well, actually, let's first quickly delete index basic because we're not using that one. We're going to remove index large because we're not using that one. And we can actually rename index redis to index.py. Okay, now we just have one index.py code index. We can open it up. That's the one we were just editing. That's going to make things a little bit more simple, straightforward for editing. Okay, so we can now invoke this Python 3 index.py. We can switch over to the browser and have a look at it in action. If I invoke this app again, I can see that my changes to the documentation are already reflected here. And the nice thing is, if you're using this debug mode, I can make other changes without even terminating the application. And they should be immediately reflected in the UI. The application gets automatically redeployed. Yeah, so we have this nonsense here. So that's one nice thing about using debug mode. In Dash, you can turn it off before you actually deploy your applications. Okay. Okay, so the next thing I'm going to do is remove some of this stuff we don't need. So I'm going to remove these parameter definitions. I'm going to remove, we're going to just keep this sidebar text 3, which is whether we want to submit the job to the queue or not. Okay, everything else before can just get removed. We don't need these components anymore. And content of resources. We can also remove. This is just a raw text field where users can enter what they want, but we don't actually need that. We just want the submit button, the sidebar text 3, and the corresponding drop down, which decides which queue it should go in. I will actually also add a third option here, which is just going to be local, which is how we're going to start. Excuse me. Label is local. Value is local as well. Okay, this will give us a third option in our dropdown. We forgot a comma here, so the app stopped, of course. And now you can see also, we can switch back to the browser. We see immediately that the third dropdown option, well, we should see immediately that the third drop-down option, local, has now been added here, and the rest of this stuff has been removed. So we just have the charge switch, the queue option, and the submit button. Okay, now that we've done that, the first thing we can start to do is create our callback, which is going to disable the submit button if the user is not authenticated. So I'm just going to collapse this sidebar just to get it out of our way for a moment. I'm going to collapse the modal, the alerts. We're not going to edit any of this stuff. We just want the modal and alerts just like it was in the template. We have our documentation content. We can collapse our app layout. And we have this modal confirmation function. And now the next thing we're going to do is just make it so that the queue and the sidebar button are disabled when the user is not authenticated. So first thing we're going to do is check the ID of these components. So the ID of one of them is queue. The ID of the other is sidebar button. So queue and sidebar button need to be disabled when the user is not authenticated. How are we going to do that? We're going to define a new we're going to register an app.callback. We're going to give it two outputs. Output target 1 is going to be the queue. The disabled parameter of the queue. Output target 2 is going to be the sidebar button, we said, and disabled. And those are our two output targets. The input targets, which you can use in any of your callbacks, they're built into these templates, is the token data. This only gets updated whenever the URL is changing. So whenever the URL changes, whenever the app is invoked, whenever the token is removed, whenever the URL changes, this token data component changes. This is the one which contains the actual data that we extract from the bfabric authentication endpoint. And whenever the token changes or the URL changes, this token data component changes as well, and then we'll trigger this callback because we want this callback to get triggered anytime the token changes. Input also entity data, and this is another browser cache data component which you have access to by default, and this contains all of the information about the underlying entity from which this app has been invoked. And we'll show that again. We'll show how that works in a little bit. I'm going to define a function, disable queue, token data, and entity data. We can add a little doc string here to let people know this callback disables the queue and sidebar button if the user is not authenticated. And this one's going to be really straightforward. So if token data is none, which it is if the user is not authenticated, or entity data is none, which it also is if the user is not authenticated, then we return to our two output targets here, true and true, because we want them to be disabled and disabled. Otherwise, if it's not none, that means the user has logged in, has been able to authenticate. So by the way, if there is entity data hydrated within the application, that means that the user has successfully authenticated because they used the web service information that they got from the application, takes the token data, which includes the web service password, and then uses that to query the entity data. So if the entity data is here, that means the user has indeed authenticated, and we're safe to return false, false, enabling these two output components. So now let's just double check that indeed the queue and sidebar button are disabled when the user is not authenticated. So let's open the browser here. We can open up localhost 8050. And yeah, I'm clicking, I cannot submit, I cannot click. And if we invoke it from bfabric, boom, there we go. We're authenticated, we have our queue selection, and we can indeed submit. Okay, so that works as expected. Okay, so the next thing I want to do is make it so that when the user opens the app from a data set, that the data set is also rendered in the page, that they can visualize the data set in the main layout. So I want the output target to be something from our app specific layout. It's going to be this div component here, the page content. So we're going to have our output target is going to be the page content. So we're going to register a new app.callback with the output of page content children. So the children is everything which is inside that component. And the input, this is the component which is going to trigger this function, is the entity data, which you always have access to by using the template. So def update page content entity data. This input target is sent to the function as a parameter. So first thing I want to do is just if not entity data, we return no auth, which is a built-in component which you can import from bfabric, from the template actually, from generic.components no auth. This no auth, we can take a look at the generic components. No auth is just a set of div children, a list of div children, which just says you're not authenticated, please log in to bfabric. Okay, so that's what I want to return if there's no entity data. Otherwise, if there is entity data, then I'm going to get the dataset data from the entity data. Maybe first I want to print the entity data so that you guys can see what's actually going on here. I'll just return nothing for now. So I'll just have this function which is printing out the entity data so you can see what this looks like. So here we have the name. This is the name of the entity. We have created by, we have created, we have when it was modified, who it was modified by, the name. All of this is inside the key, so this is a bit hard to read, but the main one we're interested in here is the full API response. So when this page is rendered, an API call is made to the bFabric web service to grab the object which it was invoked from. So in this case, it returned this object, which is a data set, class name data set with ID 59382. So what we're going to do, we're going to get the full API response from the entity data. That's a common theme throughout this application, as you'll see, data set data equals entity data dot get full API response. We always use this get function rather than indexing the dictionary directly, because then I can tell it to return an empty dictionary by default if this key is not present in entity data for some reason. That should never occur, but in case, this saves you from some bugs. Okay, so we're often running this entity data.get full API response. It grabs all of the data from this data set from which we invoked this application. So this is our data set. When we run this, when we invoke the app, it hydrates this template with entity data about that data set, and all of the data about the data set can be accessed from this store component entity data. Okay, that's enough about entity data. If data set data, so if it's there, then dataset ID equals dataset data dot get ID, otherwise none. And then if dataset ID, so if there is indeed a dataset ID, first thing we want to do is convert the dataset to a dictionary, and this can be done using the helper function dataset dict equals dataset to dictionary of dataset data. And it looks like we're getting a warning from VS Code here that this function has not been imported. So we can just go up to the top here and import it from bFabric WebApps import dataset to dictionary. And what this function does is it takes the API response of a dataset object and just translates it into a dictionary, which looks like this actually. So this dataset dict is now a dictionary with column 1 and then a list val. So this is kind of what this dataset dict looks like now. Column 2, it just massages this dataset entity data into a more parsable dictionary format. And it's also helpful because now I want to use pandas to create a data frame. df equals pd.dataframe.fromDict, and the output of this dataset to dictionary function can be immediately fed to pandas. And we want to orient by columns here. Okay, looks like we're getting another warning from VS Code. So we need to import pandas as well. Import pandas as PD. So now we have our data set as a data frame, which can be immediately converted to a dash table. I don't really want to type that one out, so I'm just going to copy and paste it from another app I've built. Here we have our table equals dash table.data table. Dash provides a pretty nice table component which you can use out of the box. We have these parameters ID, columns, data. You can take a look at the dash documentation to see what other kind of parameters you have when defining this table. And again, we have this warning that we need to import dash table. So, okay. From dash import dash table. And indeed, we don't have pandas in our environment because we never installed it. It's not included with the template applications. Yeah, here we have our error when the app tried to refresh, no module named pandas. So we just need to pip install pandas. And this is going to install pandas to our environment. Okay, that's great. And let's just double check that this is running now. Great, so the app runs and we're almost done with our callback. So we now just want to return this table, return table. Otherwise, so this is now, if there was no dataset ID found for some reason, then we would return, we just think about different edge cases here, html.div invalid dataset. And if there was no dataset data from the full API response, this could happen if a API call to bfabric fails, they might need to refresh the page, then you should just return them something so they know what's going on. Return html.div no dataset found. Maybe you can even try telling them, please refresh the page. Yeah. Okay. So now we have defined our layout page content target. We can try refreshing that now and reloading the application and checking out the browser. So this is an old instance. Let's try invoking again. And very nice. This data set which we invoked it from, we have this data set here, and it's now additionally displayed right in the UI of the app itself. So that's kind of a convenient, nice to have. All right, let's go back to VS Code. So the last callback we're going to write is the really important one. So this is the submission callback where we actually want to submit our application to be run. So I'm going to define app.callback. And actually, the only output targets that I really want here are the alerts. So this is just what's going to alert the user if the app was invoked successfully. So output, alert, fade, success. And we're going to update the is open parameter of this alert object. We can have a look at the alert object just so it's clear what we're updating here. So these are the two alerts. We have alert fade success and alert fade fail. These are the IDs of the different output targets we're going to use. And we want the success one to be opened if the pipeline was invoked successfully, and we want the error one to be opened if it was not. So we can close this. We can now collapse our other callbacks that we're not working on. Collapse this one as well. And set up our alert fade success output target and output alert fade, come on, autocomplete, fail, I think it's called, is open. So these are our two output targets. And our input, actually, the only thing which should allow this application to get invoked is if the users click the submit button. In all the apps, the final submit button, in all the templates, the final submit button is called submit and clicks. And you can find it here, actually, in this modal. So this modal opens up when they're finally ready to submit, and then this inside the modal footer, there's this button, yes, I'd like to submit, with ID submit, and this is how the users actually invoke the application. So it's only this button that I want to invoke the actual application. But I want the app to also have access to some other data, like the state of our queue component. So I want the app to know whether or not it's in the light queue, the heavy queue, or the local option, which we added. State of the entity. I'm passing entity data as state to almost every callback because it's almost always important. State. We can also grab the token data, another built-in another built-in state component. This is just token data, which is cached in the browser automatically. State app data. This is the data about the application. This is another API call, which is made automatically. You just have access to this by default when using this application. And then state URL search. This is the raw token, which is passed to the URL as a parameter. And we don't want this callback to get invoked when the page starts up. So we're also going to pass this parameter to the app.callback registration called prevent initial call equals true. So that's going to stop this function from getting invoked on app startup. And now we just need to pass these parameters to our submit job function, and clicks, queue, entity data, token data, app data, and the raw token, yeah. Okay, we can also here add a little doc string. This callback handles the invocation of the NFC hello world pipeline when the user clicks submit. We have our escape characters there. Yeah. Okay. Now the first thing I want to do is just quickly show you print entity data so that you can kind of see what's going on in the entity data. Although we already did look at it once, maybe it's helpful to remind ourselves which data is stored automatically by the entity data. Yeah, submit, yes, and now it has indeed printed out all of this entity data. So we have our entity data here. This is the full API call with some details about the data set. And then maybe it's useful if we also print out the app data so you can see what that looks like. Let's have a look here. I will invoke it from the browser. Click submit. Yes, I want to submit. And then the app data should have been printed. App data, there it is. The ID of the app, the name of the app, and a description of the app. So this data you also have access to by default by using these templates. Pretty convenient. Okay, so the input target is the submit button, the end clicks parameter of the submit button. This just tracks how many times this button has been clicked. And we're gonna just say if end clicks. Now the whole point is we need to create this run main job function. So run main job is gonna be run at the end like this. So this is basically the same in every application that you're gonna write in this paradigm. Is we're gonna have these arguments and we are going to we have these arguments and we're going to invoke them using, we're gonna pass them to this function run main job, which is gonna, is the whole point of this application actually, is to run this run main job. And we need files as byte strings. This is any files that you're gonna pass as input to the job. We have a list of bash commands. These are the actual commands which are getting invoked on the compute server. We have the resource paths. This is going to be the path to the resources that you want to connect to the underlying work unit. The attachment paths. These are any attachments which are going to get attached to the original source entity. So in this case, this data set. You need to pass the raw token so that run main job can also authenticate against bfabric. you're going to pass the service ID. This is the service ID of the charge which you want to get created, and then a list of container IDs that need to get charged for this run. And then as well, the dataset dictionary, which we're going to create. So we're going to create another this app is going to create a new dataset as well. So we just need to first create this files as byte strings variable. Files as byte strings, and it is exactly what it sounds like. We're going to have something called attachment1.html, and we're going to pass a byte string. We can just write some HTML code here. HTML body h1 hello world. Then close it, h1 body HTML closed. So we're going to create a file called attachment1.html, and we're going to do that using our bash commands, which we're going to run. So bash commands are going to be echo hello world. So we're going to just print hello world to the command line. So we're going to see how that actually looks in the end. Nextflow, this is where we're going to run our actual Nextflow app. Nextflow run hello. And we're going to write that to home griffin scratch hello.txt. So we're going to create, this is going to create a file called attachment1.html, which is going to be stored wherever this application is actually getting invoked, wherever this function is actually getting invoked. So this is going to create a report. These are the bash commands which are going to get invoked when this function is called. And then we're going to specify the resource paths. Resource paths. In this case, it's just going to be a link to this file here which we made. So the keys of the resource paths need to be file paths, and the value needs to be the container ID, which we actually need to define. So we can get the container ID pretty straightforward. Container ID equals entity data dot get container. So we get the container from the entity data dot get ID none. Okay, so if it is indeed none, well, actually, let's not make it none. Let's set it to some default value so that it doesn't ever fail to actually create the resources, just in case. Okay, now we're going to tell where we want our attachment paths to go. So yeah, in live, this files as byte strings might be used to copy over sample sheets or config files before running the bash commands. In this case, I'm just copying over a byte string to some file called attachments1.html to then later attach it as a report by specifying it here in attachment paths. And this is where, in the attachment paths, you specify which files you want to be sent, to be attached to the original data set as reports, as links. Attachment1 HTML. Okay. So the first part here is just a path, and the second part here is a name. So we just name it the same as the file name. And then the last thing we need to do is create the actual data sets, which we're gonna create when invoking run main job, and that's gonna be specified like this: dataset dict, And we need to make sure the dictionary keys are always strings. Container ID, so the keys should be container IDs, and the values of this dictionary should be the actual dataset dictionary in the same format that was created back here in this callback by this function, dataset to dictionary. This is indeed the format that we're using to pass these values. So resources, we can just double check our dataset template actually to make sure we're getting the column names right. So if we go to our dataset, the dataset template we used is ID number 14. That's the one we're going to create a dataset. And here we have a column called resources, which just takes string values, and a column called attachments, which takes string values. So that's how we need to specify this dataset. Resources, hello.txt, that's the resource that we're creating from this hello world invocation. We send it to hello.txt. And attachment 1.html. So, and then this is actually going to fully parameterize an invocation of this bfabric run main job function. Shall we give it a try? Let's do it. So here, oh, actually, first, seems I have an error. Yes, because I opened a try, but I didn't handle the error case. So exception as E, this is good form. Let's just print out the exception. We're gonna print, error creating work unit from error E, and then return. Let's check the output targets. So we're gonna return false to if the successful one is open, and true to the failure one is open. So we want to return false, true. False, true. And in this case, if there was no error, we want to return true, false, because we want the success one to be open and the failure one not to be. So let's see how that looks in the end. Let's open this up. App is starting up again when I save it. Let's go to the browser, invoke, we can refresh this even, and let's invoke this job. We have our data set here. Our charge is going to get created. Let's go. Yes. And now, if we switch back quickly to VS Code, you can kind of watch this happening in the back. So we have attached hello. So actually, this pipeline was already run. We attached the hello.txt to this work unit. Yeah. We attached it, created a resource for it, sent it to the final remote path. SCP was executed by TRX copy, so it copied the attachment. Yes, all of these steps are done automatically for you. You just need to specify what files should be resources, what files should be attachments, and whether or not to charge the container. So it's pretty easy to have fully data integrated pipelines. And now if we go back to the browser to take a look at this, we have the success message. Yes, work unit created. And if we go to the work unit, actually first let's just take a look at the logs. So this is kind of cool because by default when you use this run main job function, everything is getting logged, not just from the UI, but also from the actual run main job. So we have all of these token validated messages. I actually can't see this on my screen. Maybe I need to pull it over. Come on, how can I make this bigger? Yeah, let's just zoom out a little bit. So I'm authenticated. This is, I probably clicked refresh a bunch of times. And now, okay, bash commands executed success. Run main job executed this echo hello world function successfully, and then it executed this nextflow run hello function successfully. Work units for batch processing. Yes, we created a work unit, total created work units, and then we have the work unit ID. We have our attachments. We have our charge, which is created, and we have a message that all steps were created were invoked successfully. So that's pretty convenient. Just from, yeah, maybe 200 lines of code we wrote today, we have a fully functioning web application. Now, one other point I want to add is that this function is actually getting invoked locally wherever the web app is running. It's invoking this run main job locally, but we don't have to do that actually. Remember, we had 3 options in our queue dropdown. We can actually say only if queue equals local do we want to run it locally. Queue is, remember, the argument which is passed from the queue value parameter from our input target queue here. We're grabbing the value. So if the value here, local, then we're going to run it locally. Otherwise, let's send it to the Redis queue, yeah? bfabric web apps dot run main job arguments. No, that's not it. bfabric web apps dot queue. We have this function queue in the bfabric web apps library, and we just have to tell it the queue name equals queue dot enqueue, and then we have bfabric web apps dot run main job is the function we want to enqueue, and the keyword arguments equals arguments. That's this dictionary we passed. Okay, and let's see kind of how that works. So that's a little bit even more user friendly because yeah, you don't have to wait for the UI to run this whole job. Indeed, if you're demultiplexing genomic data sets, you won't have time to sit and wait for this job to get finished while the UI is rendering. So we pass it to the Redis queue like this. So maybe before we continue, let's just also see that everything was invoked successfully before. So we have this work unit which was created, added to this work unit tab. So that it knows that this job created this work unit, and it was created by this application. It has this resource, and indeed it has the hello world dataset which we created automatically by passing the dataset dictionary to run main job. So all of these data integration features just work out of the box. Pretty nice. You have the work unit linked to the job. You know, you can see it here in the job. Yeah, we have the work unit linked to the job. The work unit is linked to the data set. It's having the resources attached, has the NFC hello world. And if we go back to the original data set that we invoked this from, which was ID dataset demo app test. Let's see if we can find it here. Datasets. If we go back to the original data set, yeah, then we can see we have this new attachment here, which indeed is hello world. Cool. So now we were just setting it up so that you could run this via Redis rather than running it directly in the same environment that the web application is on. If you want more details about that application architecture, I advise that you take a look at the video that we made about the Redis template. It has all of the architecture details there. I'm not going to go into detail now, but I just want to show you how this is all done. So now here, the nice thing is that if we select like heavy queue, let's just check the queues quickly. We have no jobs in light. We have no jobs in heavy. We can submit this job directly to the queue. Error. Let's take a look at the error. What was the error? Queue has no attribute enqueue. Ah, sure. So I actually spelled the name of this function incorrect. That is why. NQ, these things happen. NQ, okay. Let's try that again. Okay, browser. Let's send this to the heavy queue, submit, and success, working to create it. Yeah, and we have one job in the heavy queue. The thing is, I didn't start a worker yet. But if I start a worker, then we'll be able to see. Let's just try starting a worker now. If you want details on that, please check the Redis deployment video. So I just deploy a worker on this server which I specified here. So in the .env file, cat.env, I specified my Redis host, and now I'm just starting a worker on that server by running this script, python 3 scripts worker.py, and that's gonna just run a worker for us. Oh, and you can already see that it is doing some work. I guess I had some stuff in the queue already. Okay, but that's not from our app because we submitted it to a different server. I'll run the worker for him, and we can see, oh, okay, it's running, and we can see that the status is completed. So I hope that was clear. Takes some getting used to, playing around with the Redis architecture. I can quickly show a refresher what that looks like. So we have the web server here. We have the compute server where things are actually running. It's listening to this Redis queue. Everything is fully integrated with bfabric. And with that, we have created a fully working application. Pretty cool. So this application that we built together today is 260 lines in total. It took us around an hour to build, and we have a fully working nextflow pipeline running fully integrated with bfabric. So that's pretty cool stuff. So the last thing that I want to say before we go is feel free to reach out to me directly if you have any questions or feedback around development of these applications. I'll be happy to get anybody set up as required. And then with that, I just want to say thank you very much for your attention and have a nice day. Bye-bye.